Welcome, everybody. I hope you enjoy the coffee. Fast data architectures. What is fast data? What is all this buzz about streaming? Companies are going and adopting streaming as a means to gain insights of the data faster. Data as data arrives into their hands, into their systems. And it's been a challenge for many companies or many enterprises to figure out how to architect, how to build up the systems that are able to handle that load, and I'll handle it 24/7 as I do with, let's say, regular applications. Today, we're going to talk about how to build architecture for that. And for that purpose, I'm going to start with an example of a use case that we have done with a customer. And let's start, like, what are the patterns that we can see there? What could we reuse? And what kind of tools can we make and can we build to take those patterns and create like building blocks to do or to create our own fast data platforms for our applications. I'm Gerard Maas. I work for Lightbend, the company behind Scala, behind Akka. And now we are heavily focused on also the fast data market with our fast data platform. I personally work on the fast data engineering team in a project that is aimed at creating tools to make the life of developers much easier. This morning, there was this quote that was saying that we make the tools and the tool make us, so I don't know what they are making out of me. But that's what I do every day. I am also the author of stream processing with Apache Spark. It has just stolen 18 months of my life, for hopefully will be done by the end of this year. Please go buying it for Christmas gift or whatever you want. And you can get in touch with my coordinates there. I've been also involved in the open source environment and open source community for a while. I was an early adopter of Spark. I have been a Cassandra MVP a few years. And, of course, an enthusiast of Scala. And today, we're going to see some code, something maybe going a bit more into the details. I believe that as architects, we need to have a feeling of the tools we are using to create things, a feeling of the materials we use to create our buildings. So we'll go a little bit into tools, a bit into code, and try to put it all together for you. I mentioned Lightbend. Sometimes the company doesn't ring the bell, but we have been out there. We power the technology of many companies out there. All the big data stacks are important big data stacks that have been built in Scala, like Spark, like Kafka. We have Akka, which is an actor system, highly scalable, a very low latency to keep state distributed. And then we have Akka cluster as well in play for creating web applications, Legom, an open source framework to create microservices. And today I want to talk about streaming, why it is important, how it looks like, what kind of patterns can we see from that, go into a quick demonstration, really get our hands dirty, and then discuss a little bit about what we see about what is the path forward. How are we seeing these trends coming together into let's say, a common space? Why streaming? Well, I kind of gave the nutshell explanation of that at the beginning by saying we need to get insights from data faster. And one of our customers, so there are a few customer use cases you can read on our website. I'm going to focus on this one, HPE. I've been personally involved in this project. I helped out in a very small area, but was really kind of a complex way of duplicating some streams. And so I would like to give you a bit of the highlight of how that project looks like. What is in this particular space, a space about HPE, what they are doing is predictive analytics, and they are applying machine learning models to telemetry data coming from their devices. That is to trigger some kind of potential actions that will prevent failure, will prevent failure from expanding or kind of replacing the equipment. So the equipment we're talking about is storage. They have a storage unit, they sell it to you, enterprises install them in their racks, and they have it running, you forget, you sleep good every night. While they have this telemetry service to capture events coming from that storage system. So I am hard disk, whatever they're using, flash-based. I am disk, whatever, and I have seen some error rate going up. And then that is posted to their telemetry service, and all these anomalies, all these events are then scored for a given anomaly score. And if possible, then some corrective action is given back to the device. Their architecture in a high level, it looks like this. So they have Apache Kafka as the, let's say, the backbone for the event exchange. They have all the events on, the devices are on the field and around the world. And their flow, their data flow, it consists in like 3 main areas. The first one is capturing the data. And that capturing the data has to do with the closed circle here with some microservices that are fronting all the interactions with those devices. So the devices, they are publishing information. That information goes to Kafka. There is something else happening here, but then those scores and those messages that need some communication back to the devices are going through some microservices that can communicate with the remote devices. So they are RESTful services, and they keep some kind of sense which device is where and what state they are. Then we have the interesting machine learning scoring. That means that we already have a model somewhere that we have created by crunching data, by understanding what the failure looks like, and by figuring out how a model that would predict that failure would look like in terms of implementation, in terms of parameters. Once that all work is done, as the work typically of a data science team, we are going to have to serve this into production, into an online environment. And there is where these low-level microservices are playing a role. They are going to implement the model serving part, both in terms of acquiring the latest parameters as well as doing the scoring online. Last, we have the model training part. The model training is the specific job that is looking at segments of data, really large chunks of data, and then trying to train that model that has been created beforehand, and then create the parameters that are then given into the microservices that are doing the scoring. The flow looks more or less like this. So there is this telemetry coming in from the devices. Those values are going into Spark in a regular base. They are consumed from Kafka in chunks to train or model. The updates are going into Kafka again, so we are using Kafka, as you see, as the interaction broker into this architecture. So the parameters are going back there, and then also stored in the database in case we need to retrieve them at a later stage, and then consumed by our microservices that are going to implement they're too fast, are going to implement the scoring. So we have a double flow here, and of course, it's happening at different stages, different topics in Kafka. Once we have detected some events that need some attention, those are published back into Kafka and then given to the front-end microservices that are able to communicate the corrective action back to the devices. This is how they have implemented it at a high level, so there are lot of details, of course, we're not seeing there. But it's very interesting to see the patterns. So we have like a messaging infrastructure. We have interactions going through there. We have some asynchrony between or among the different elements participating in the architecture. And that leads us to kind of reason, what are the building blocks? What are the pieces that we need to construct such an application or such a platform ourselves to serve our own purposes? Let's try to get out, so take the little components and the specific situation out of it and extract some of the important patterns that we see there. First one, every architecture starts with a dotted blank canvas, and it's our task to fill it in. And before we rush into kind of saying, okay, I need this and I need this technology and I need to run everything real time, there is one step that is very important, especially it's always very important, but in this particular area, it's crucial to understand the requirements of your application. And it sounds trivial. We architects, we do this all the time, but the latency, throughput characteristics of our use case, how fast is fast? How fast do we need to react to a message coming in? Can we wait a little bit? How much storage do we need? How large my cluster needs to be to handle all the data that we are expecting? Is there seasonality in that data? Are there some peaks? Do I need elasticity when I consider building my system? Those are all questions that we need to have a grip on beforehand in order to select the right pieces that are going to constitute our platform. And then what kind of processing are we going to apply? Do we want to do a kind of offline reporting? Some financial institutions are more into dashboarding. The IoT environment I've been personally involved with, they are more into consume huge amount of data, so your ingest has to scale really, really big, but then the output of it is like, oh, I would like to see what this device did in that day, like an aggregation. So ingest really large, really amounts of network and throughput that you require to accept all that data, but the storage might not be that large at the end because you are going to aggregate all the different events in real time before writing them somewhere. And last but not least, how do we build, deploy, and manage those services? The tool chain for some of the services is disparate from others, so we have typically like the microservice environment that has a given mindset and a given workflow, and then we have the data services. And the data services, they are typically based on a cluster. They have a different set of scalability requirements and scalability patterns. They throw data and they work out into a cluster. So, and how is that cluster looking like? So once we have that grip on the questions that we need to answer, then we need to first lay down a substrate. Where are we going to build? And now we are architects of building buildings, or building a house, or building a very tall skyscraper. The first thing is substrate. And today, there are several options out there. The two of them I would consider are Mesos and Kubernetes. Kubernetes being a container orchestrator, so Kubernetes is now like big hype, and everybody is really interested in running things into Kubernetes, having your container, just make a container, drop it into Kubernetes, and let it have resources. The core task of any of those two systems is to give you access to resources in an automated way and to give your enterprise agility. Because you then don't require to have a machine, a VM, no, I need to call IT to have a new deployment. No, you just need CPUs available. You just need memory available. You just need disks available. And sometimes you need affinity to whatever specific hardware you have out there. But in general, what you want is a small set of resources for your application. And then your application is successful, you can scale that up. All right? Mesos has been out there a bit longer than what Kubernetes is, at least out there, I mean, the open source space. It offers you a bit more than Kubernetes in terms of the facilities that you have to schedule load on a cluster. But then again, you have Kubernetes everywhere. So it's a balance between how much flexibility, how much power do I need in the way I schedule my jobs on the cluster versus can I run it anywhere? Can I run it in Google Cloud? Can I run it in Amazon? Can I run it on-prem? Et cetera, et cetera. Kafka. There are very few options out there in terms of a messaging backbone. key requirements here is that you want to decouple your producing side from your consuming side. This creates flexibility, creates freedom. Your producers that are delivering you data at any point in time, they might go down, they might come with many more at one given point in time, and data starts like, okay, it's coming up at a higher pressure, but there is something in between that will hold that pressure. At the side of the consumers might come on and off, might be interested in some parts of the data, might be interested in real-time communication or real-time collection of that data, might wait maybe for a few hours before they capture a snapshot of what has been seen in a given period of time. The patterns are very different. An important thing is that this gives the flexibility, the elasticity in the middle of the consumers and the producers to negotiate that load handling, that giving my message from one place to the other. Another very important pattern that we see in the backbone, in the messaging area, is to offload from one messaging pipe, topic, onto another. So you have applications that are starting to build up and create new digested versions of your messages by publishing them again and making them available for other applications to consume. That way, you build up what we were calling a pipeline, applications that communicate with each other through messaging. Now that we have a infrastructure, a substrate where we can deploy things, we have Kafka that is providing us our messaging infrastructure or backbone so we can send and receive messages. We need something to process those messages, and this is about data processing, about consuming the data, applying some logic to it, applying machine learning, applying any kind of aggregations that you have there, applying business logic. I had a customer that were applying billing rules to the data that was coming in to produce bills at the other side. So the flexibility there is all programmable, and you have many different choices. And the choice to make relates again to the requirements that we were capturing at the beginning. Are we having this requirement that I need a millisecond response at the other side? Then maybe we will have to scratch Spark from there and maybe go to Flink or maybe go to Kafka Streams or Akka Streams. But then we are sacrificing throughput, because if you are handling each message independently, either we need more resources or we just have a limited throughput of the messages that we can handle. On the other hand, when we have a very large input of messages, in the use case I was telling about, this IoT cloud infrastructure I worked on, we were consuming all incoming data, with Spark streaming, and now you have a structured streaming there as well, because they scale up massively. So when you have really large amount of data coming in, the scalability capabilities are impressive, and you can handle that load by adding just more machines to your cluster. All right, so we have now in that space my Mesos or my Kubernetes or Yarn, if you still have one of those running. We have Kafka now. We have a streaming engine. We make choices there. Maybe we need one, maybe we need two. We can combine them together. We then have microservices. The microservices space, it's about breaking down these large monoliths, as they were called before, or they're called now, and before they were called just large applications, with the goal of gaining agility again. So you want your services to concentrate on a given problem, and only that given problem. And communicate using messaging with other services. Just like I showed before, the microservices that were reporting or sending the messages, the actions back to the devices, they were receiving then information from another set of microservices that were data connected. So we see there the flow from one area of one world to the other. And last but not least, we also need storage. If we are consuming data, we need historical records. We need to preserve the information somehow. And then we have there many options. The scalable options, cloud options, depending on the use case, what are you dealing with? Are you dealing with really large amount of records? Let's say an electricity company is kind of storing smart metering readings every 10 minutes, every 5 minutes. You will need something really scalable. On the other hand, if you're dealing with customers, with partners, with a very related data structure that fits better on a SQL database, that's your choice. It all depends on what problem are you tackling. And we then add a layer of monitoring and management, because we all want to sleep good at night. So when these things are failing, we need to know there are already a lot of measures that the systems themselves can take. For example, Kubernetes, if you implement health checks, Kubernetes will restart the service if that service goes down. So that first action is already automated. But what happens if that service goes down and down and down, and you see a spiral of death coming to you? Then there is an action, there is something that your team, your technical team needs to do, and that's why it's important to have that monitoring and management that gives us a view of the status of the system as a whole, as a holistic view, instead of what before was happening, like the log files from one system and the other. Now we are more interested into understanding that our business process is running today and right now, from one end to the other. At the end, of course, we don't do anything with our platform if we are not connecting it to the outside world. So there are kind of inputs there, whatever you are connecting with, maybe partner system, maybe devices out there, maybe you are getting the files. I see that very often, they're like large uploads of files as a communication means. And I would like to show you a quick demonstration of how we can put all this together. And what I'm going to demonstrate today is a project I'm working on. So it's very alpha. It's not out there yet, but I believe it's solving some of the problems that what you were dealing with in the space of having an end-to-end approach to data or fast data application development. The use case is really very simple, and to bring it as a quick demonstration for this presentation is based on a real customer scenario where they have a network out there. The network is producing call detail records, so it's a telecom provider. And those call detail records, they need to be consumed, aggregated, and then put in different systems. There are different granularities. High-level granularity goes to a dashboarding system. Low-level granularities, it goes to storage for usage of different applications within their organization. I have just summarized the process into gather the data, process the data, and output the data to make things simple to understand for today. And that gathering of data is based on a schema. So we're going to represent that data using the information, that the shape, how that data is looking like, so that we don't have to start writing parsers or whatever ourselves. We will just say, this is the data I'm expecting. If the data doesn't fit that purpose or it's not that shape, then it becomes an error, and otherwise it enters my pipeline without issue. I have created this as a project in 4 different parts. I'm going to show very briefly how that looks like. My project has a data model that represents the data that is coming in. It has an ingester that is the HTTP endpoint that is going to receive those data points from the outside. The Spark aggregation implements all the window querying that is happening on the data as it flows through the system. And then it's a very simple output there. So I didn't connect the database at the end. I just put it out to the console in order to show it to you. All right, so let's see. OK, I have a project here, and that project contains all those folders. The first thing I would do, so the project is already created and programmed, of course. It consists of some classes implementations of my ingress. First of all, the data model. So the data model is contained in some Avro schema representations, and I have some sample data to trigger some of the tests. Sorry. Then I have my ingestion endpoint that provides me that HTTP endpoint and the streaming version of this as well, where once deployed, it opens up also a port so to be able to receive the data. And I have an aggregation that is implementing window aggregations. And one of the things we have done is removing a lot of the boilerplate that you have to write to create those services. So here, I don't know if anybody familiar with developing Spark applications? All right, so I'll briefly explain. This is a SQL-like query language that we are applying on the data that's coming in. So it's the in data set that's there. And I'm saying there is a timestamp on the data set, and there is a watermark. So anything older than 1 hour, it won't be part of this aggregation here. And then I'm going to create windows of 1 hour based on that timestamp. And then finally, I want to transform this into the schema I require to write out. What is not here is all the setup, all the connection to Kafka, all the boilerplate code, as is called normally in our jargon, to create all the connections internally and to make that process consume the data in a session in a reliable way and keep it running all the time. So this is actually provided by the tools we are working on. Once that project is set up there, we're going to publish it. So we are going to create Docker images. Docker. All right, so Docker images will be created for you using a build tool. I am not going to do that today, so typically you will do this, and you will create and publish those Docker images. And then at this point in time, we have a application that has been containerized. There are containers for each of those components there. My application consists on a set of microservices and an aggregation component using a Spark, data processing component. I put it together, used this. So I'm going to make a blueprint out of this, and what it's saying, I have an ingress, and this ingress is implemented by this long name. I have an aggregator. Again, this is an implementation of it. I have few egress. I have one egress here, and I have connections between those components. So I created my services, some microservices, some data aggregation services, some data crunching services, and now I am putting them together into a sequence of operations, actually not a sequence of operations, but a sequence of services, and they will be communicating using messaging. And once that's done, I can say, I want to deploy this. All right, and of course, we want to know when this is ready. So one of them is running, I still have one pending. The pending is the endpoint, so once the endpoint becomes available, I will be able to send message to this application. And okay, come on. Still pending. Well, typical demo scenario thingy, I don't know. But let's have a look how that is showing up in Kubernetes. So I am running Minikube. This is a full implementation of Kubernetes running locally. And here we deploy, of course, some of the infrastructure that we talk about. This is very small. So let's put it. Some of the infrastructure that we talk about. So we have Kafka there using an operator called StreamC. We have Zookeeper. We have a Docker registry. We have our enterprise console for monitoring. We have our platform deployer. All services are available there. Those are services that are provided by the system, implementing all those blocks I talked about before. And if things went rather well, then I should have an application as well. And there's my application, and it should have some, oh, sorry. My application is here. Come on. There we go. And then we have my application, and that application contains those 2 pods. Those pods are running the data points, or the data services. And there we are. So we have deployed everything. The endpoint is there. Once the endpoint is there, I can send some data to it. I see this is just an HTTP endpoint, so I'm using just a simple HTTP client to send data. And once the data starts flowing into the system, then there are other things I'm interested in. So I'm not only interested into having my Spark and my Kafka running, but I also want to know the health of the system. So we have there some Grafana dashboards that will give us a view of my HTTP ingress as data starts coming in. So there we have the data, just started it up, and the flows of data will be charted there, kept metrics in our monitoring environment. All right, and after a few minutes, so we are consuming chunks of data. If you remember, my query was of 1 hour. I need 1 hour worth of data to start producing some results, and the results should appear there at some point, but it's not there yet. But I will continue. Maybe if you want to see the results, I will be on my stand there after the presentation. I would like to continue with with this part of the talk. There we are. With the future, what is this? What are these trends bringing us to? Where are we going? We believe that the current movement of the technology as we see today, there is getting together from 2 different forces. One is big data. Big data has been big for the last 15 years. We started with Hadoop. We have all the revolution of MapReduce taking over a lot of the data warehousing activities of, let's say, 5-10 years ago. Now we see that big data movement is going to faster movement of the data, so we are moving to faster data applications. And from the microservices spectrum, what we see is that the microservices require that data to operate. They are now based on the same interactions. They are all message-based. So there is an interaction between those 2 worlds, and we see them coming together. There is a third axis coming here, and that's that of container orchestration. So if you hear the vendors here today, Kubernetes is taking over the infrastructure world, so to say. Everybody wants to deploy things on Kubernetes, and this is allowing us to create applications that can run on your infrastructure, on the cloud infrastructure of today, and the cloud infrastructure of the other that you didn't consider at the beginning. So you don't have to tie yourself in one of the vendors. So we have one here, so I won't call names. But you don't have to tie yourself to a specific implementation, because Kubernetes is giving you that abstraction layer to deploy where you require, or where the financial picture or the financial balance at the end of the day is the best, because there is, of course, this price fight going on. Where can I have my CPUs the cheapest? Where can I have my storage the cheapest? Those 3 things together, I think you have seen those before. And this is what makes time travel possible. This is the flux capacitor from Back to the Future. And I want to leave you with this message, the message of convergence, that microservices are becoming parts of streaming pipelines. We saw that interaction. We saw microservices consuming data from those streaming pipelines to do their work. I need the latest parameters for my model. I need a warning. I need a message that I need to get delivered somewhere. That interaction, that direction is there. The other direction, the pipelines that are implementing our big data applications, they need to be exposed. they need to give output to the world and get input from the world. And microservices are ideal for that. They are giving you very punctual interfaces, very focused on a given subset of your whole problem space that will provide you that interface, either to power a dashboard somewhere or to inject data that is coming from another system. It also gives you a very nice boundary to your system that you can understand from a high-level perspective. Those are my entry and exit points of my system, but also gives you the power of how the messages, how the data is flowing inside my scope, the scope of my system. And the third one is that the packaging deployment management of those applications are becoming cloud native from the beginning. So you can run them locally, like on my machine right now, using Minikube in my case. You can run them on the cloud, or you can run them on-prem if you do your own deployment of this set of infrastructure automation layers. And that's a message I would like to leave you with today. There are resources. I organized and co-wrote this Designing Fast Data Applications architecture. It's available from the O'Reilly website, but also from our website down there, Fast Data Platform at lightbend.com. Or if you are interested in our Fast Data Platform, a pre-built set of components that you can deploy and have a baseline for creating fast data applications, you can come talking to us at our booth there. And we have plenty of resources for you to learn more about how fast data can be implemented, what are the patterns, and what are the tools and the glue and whatever substrate that you need to get them done. And with that, if there are any questions,